Step 2, question number 13, from 2010. It's a stats question about probability density functions. It's question 6 from the stats support module. And yeah, let's get into it. So we've got a function here. Let's immediately just draw it, right? Because this doesn't look difficult to draw. Between 0 and k, x is just a, so that's a flat line at a, just going to k. And then a is a positive number, which is bigger than b, so this next flat line is lower than that, up until 1, and it's 0 otherwise. What do we know about probability density functions? Well, they must add up to 1, the area underneath them, must add up to 1. So therefore, this area here equals 1. So a times k plus 1 minus k times b must be equal to 1. And I'll put that up there just for now. Show that a is bigger than 1. Well, okay, well, the area a is just this, right? It's a times 1. And that's clearly bigger than the area that we know to be 1, which was this, because it's got this extra area here. So therefore, this area a is bigger than the area 1 we're looking for. A is bigger than 1. And likewise, b is this area. It's just b times 1. And that's clearly less than the value that we know to be 1. So therefore, a is bigger than 1. And b is less than 1. Good. Show that the expected value is this. So the expected value is usually the integral of x times f of x. Now, it's difficult to integrate this, except it's not, but it also is. Because it's a piecewise function, we have to do this separately. But then we don't really have to integrate anything, really. So I'm going to do it up to from 0 to k as one function, because it's this function there. And then from k to 1, because it's this function there. But of course, because the functions are just so simple, the integration is just really simple as well. So we're just going to integrate this and say it's x squared over 2. And this one for x squared over 2 as well. Then we're going to put all the numbers in, and we end up with this here. Now, that's not the expected value they've given, that they want us to get. And just notice that this doesn't have any k's in it. And this does. And there's good news, which is that earlier I wrote down an expression connecting k, a, and b up here. So I'm going to rearrange this one for k by just expanding out and just doing some stuff. And I'm going to put that k result in here. There's probably more reasonably easy ways of doing this, but I just thought I can probably just sit here and do the algebra. So I'm just going to sit here and do the algebra. Some stuff will cancel out from this line to give it a bit simpler stuff here. And then I think what you need to notice, two things. Firstly, you're trying to get here. What's wrong? Well, there's an a minus b squared here. So that's got to cancel with an a minus b on top. So there must be an a minus b on top. Now, if there's an a minus b on top, that means that by factor theorem, a equals b is a solution. And we can just double check we're right by putting a equal to b in here. And then if you did, if this became a b, then it will cancel with that. If that became a 2b squared, then it will cancel with this one, and so on. Everything would cancel. So a minus b is a factor. And then we just need to figure out what remains. Now, of course, this remains. We've been given the answer. So you could just write this in here. Otherwise, to convince yourself, a times by 1 is a, so we need a 1 here. And likewise, minus b times 1 is minus b. We also are clearly going to need a minus 2b, because otherwise, how are we going to get this plus 2b squared? This also gives us the minus 2ab that we need here, so that's fine. And the ab likewise, and it all just works out. Then these two things cancel. A is bigger than b, so this isn't 0. So we can cancel these safely, and we end up with the e of x just there. Now it talks about the median. Now, the median, of course, is the place where half the data is found to the left and half to the right. Now, of course, in this kind of scenario, it means that you want area a half to the left of the m line, and area half a bit more than it. Now, the difference here is that this m, it will make a difference whether this m is in this box or in this box to our value. Now, if m is in this place here, that means that a times k is less than a half. Is greater than half, because of course m is where half the data is behind it. So it being here implies that a times k is slightly bigger than a half, or equal to a half, I guess, which I'll fix later, I guess, because you could just say the equal to sign will work here. Anyway, in this case, what we'll say, therefore, is that a times k, we know k is this, remember, is bigger than a half, as we've said. We can, a minus b is bigger than 1, bigger than 0, so I can safely multiply that across without interfering with this sign, and then we can expand and rearrange, and we get this condition they wanted. Of course, like I said, you can pretend that this is an equal to sign as well, because for this case, you could be right in the middle, it's fine. So okay, we get this, and then of course, well, what have I said? Well, I've said m, which is this distance here, times a, needs to be equal to a half, so we rearrange that, and we get that if this is true, then this is as well. So that's fine, that's exactly what I wanted to get. And then show a similar thing if this is true. So okay, well, that's, of course, if m is on the other side of the line over here. So, okay, well, if it's over there, then that means that ak was much less than a half, because we need this extra area to build us up to a half, don't we? So ak is less than or equal to a half, I guess you could say, because, again, the middle line is kind of the one place where they meet. It doesn't really matter. put in k, and then obviously do the same thing we did before and rearrange, and we get the same thing we had, but with the less done sign. And then, of course, we can now say that ak plus m minus k times b is going to have to be that half. So that's the two boxes added together make the half this time. And if we kind of rearrange that for m, which I'm doing here, and then we need to throw the k result in because we probably want the result without the k's in it, right? So we throw the k result in, and then we just do a bunch of algebra. Again, I was just feeling like I couldn't be bothered to think this through. I was just going to do algebra. It will be fine. It was fine. It just worked. Here, you can again notice that a equals b as a factor, or a equals b makes this whole top row 0. So therefore, a minus b as a factor, you can figure out without too much effort that it needs to be a -1 to make this a minus a and this a plus b. And you also need a plus 2b to make a minus 2b squared. And that's just everything you need. This cancels, and you end up with this here, just swapping that over. There was actually a much easier way of getting that, which I read the marks scheme later. Of course, if this area is a half, then that means that this area is a half. So you could just say 1 minus m times b equals a half. And you would get here much faster. But whatever, I couldn't be bothered to delete my work, so I just left it as it was. Show that m is less than e of x. Often when you're doing this, firstly, I've collected all the results that we've got so far. We've got two cases to go through. We've got the case when m is this, if this, and we've got the case when m is this, if this. Let's do one by one. A nice way sometimes to show that one thing is less than another is to take the two things away and just show that it's greater than 0 or less than 0. So if we just do m minus e to the x, if I'm trying to show m is less than this, e to the x, then I'm going to try and show that this thing is negative. That's okay. Let's just hope that that comes out nicely. I'm in this case as well, I should say. I'll do the other case afterwards, of course. Let's combine these fractions together. Again, it doesn't take a genius to do any of this. It's just algebra. You can factorize out a b from there, and then you can also factorize out a -1, which makes this very recognizable as a square thing. And now, of course, looking at this, a and b are both positive, and a is bigger than b, and 1 minus a all squared is positive. So this, and this are all positive values. So this minus here is just single-handedly making this whole thing negative. So if m minus e to the x is a negative, then therefore m is less than e to the x. And then we just do exactly the same thing in the other case. And it all turns out okay. It's basically the same thing. You do some algebra that's really boring. You cancel a bunch of things out, and then you factorize out an a this time rather than a b. It's basically the same case we saw before. And you get this. This is positive, this is positive, this is positive, and something squared is positive too. And also b is less than 1, so this will be positive anyway. And yeah, you just say the same thing. This negative is making the whole thing negative. Therefore, m is less than e to the x in both cases. And this question is done. Thanks for watching.